Hello, everyone. Happy to be here. I want to give you an update of what we've been doing with Glamorous Toolkit. I've been here one and something years ago, and at that time, I described Glamorous Toolkit as an environment. Of course, it's a Smalltalk system. It's built on top of Faro, but the main goal of Glamorous Toolkit is to provide a new kind of a development experience and for making people be able to understand or reason about the inside of software systems. So on those occasions, I showed things like the inspector, and the inspector is moldable in that it can have multiple views. A typical inspector would look something like this, but in this case, we have an object that actually represents an algorithm that produces this layout, this tree map. What's interesting about this is that on the one hand, it can show me what the result is. But more interesting is that I can get, for example, all the lists here. So these are the steps that the algorithm undertook to actually produce the picture, right? So the algorithm is not straightforward. It has little different steps. So you can see it started here. And so for those that would understand the algorithm, it's kind of interesting. But for those that maybe just want to take a quick look, this is maybe perhaps more interesting, right? So here you can see, first he tried to put this rectangle over here, the second was here, the third was here. This didn't work so well, so the fourth came here and so on. And what's interesting about this, so the green ones are the successful steps and the red ones are the not successful steps. The interesting thing about this is that this picture is actually coming from the paper that we used as an input for implementing the algorithm. And that's one of the ideas of what we call moldable development. The idea is that as soon as a human being deems a representation about something inside a system as meaningful, because they wrote it somewhere or they produce it in some form, we think that it's a responsibility of the system to carry that representation forward. And it's that little system, that little idea that is at the core of everything we do. And then out of this, it turns out that there is no single way of describing anything in a software system or about a software system. And as a consequence, we think that the primary ability of an environment is that is conducive for actually working or making the inside of software systems suitable for human inhabitants is so that it's moldable, that it can take multiple different shapes, so that it's comfortable for the kinds of stories that we want to tell with it, the kinds of narratives that we want to construct about our systems. And we can construct many different kinds of narratives about many different aspects of the system. So for example, here is an example, which is another thing that we've built, which examples are like tests, but they return an object. So you can see here, I set up something, I do something with it. I have some assertions over here. And then the difference between this and the test is that it returns an object here. So in this particular case, I have an example about an editor. And this editor is a multi-line editor. And so I can look into that one if I want. And if I now go and inspect, because this is examples like tests, right? They're executable. So the environment tells me, well, you can execute this. And if I execute this, I get the preview. Now here I see an editor. And this editor is being shown to me with a little bit of an adornment that is really interesting for debugging the editor, right? So for example, positions, the cursor positions are kind of important when you're debugging the editor. And in particular, in our particular example, so we have here, this is the basic example, just an editor or multiple lines of text. But here we want to go and say, move the cursor to number 2, to position number 2, and then basically double click and see what happens. So when we do that, we basically see here, and this is a live editor, right? But we can see, we don't have to imagine what this means. And we are not looking at some raw numbers. We're actually looking at the thing that we want to debug about. And the whole idea here is that we bring the domain where the developer is, rather than forcing people to piece together these ideas by hand. This again really applies everywhere. So for example, one of the challenges we had recently or over the last year was how do you reduce the load time of Glamorous Toolkit? Glamorous Toolkit is not a minimalist. It doesn't take a minimalist approach to the core of a system. It's much more of an exploration, and we really are looking to see what would the interesting global experience be like. And in this journey, we're actually loading lots of code, or potentially can load lots of code. And we wanted to reduce this amount of the loading time, from tens of minutes to a few minutes. And to do that, the default kind of loading behavior was not good enough. So built a little tool for that. And this is basically what you're seeing here. Normally, when we look at the dependencies of what needs to be loaded, is something like this. It looks like this, lots of little details, lots of extra dependencies, right? So for other people, this is called Metacello, the basic dependency management. But we were not so satisfied with the speed of Metacello, so we wanted to have it faster. But we didn't know how to debug, or we could have debugged the Metacello one, but it was easier to create another one from scratch. And creating this one, we guided this to the creation of the loader by means of these kinds of tools. For example, right, so this is the all of it. And this is what happens when we remove the unnecessary dependencies that are not necessary for, when you're loading code, you just linearize everything. So everything that we see here on this map is actually a directive. So it's a load directive. And we can see here what gets loaded when, for example, I just chose one of the subcomponents block, what exactly gets loaded here. The full picture is slightly more complicated, but that's the only thing that we're loading here. But then, of course, the interesting things here is also, you can also take a look and be more technical. So here, for example, we're looking at the actual action. So, okay, we can see loading actions of packages, but here's a post load action, and this post load action is actually a piece of code. But then if we select it, we're going to go into the actual code, so we get to see it here. Now the interesting thing here is not that the views are super exciting, because they are not necessarily, but the combination and the bringing everything into proximity, directly correlating everything exactly to match the problems that we were looking for. That's where the differences are. Now, we can think like, what is one way to look at the Glamorous Toolkit is to look at it as a Smalltalk system, as I was saying, because it is a Smalltalk system. On the other hand, our intent and our work is broader than what can be expressed with Smalltalk. And so one of the kinds of pieces of work that we do, so we're a company, our company is called Fink, and one of the kinds of projects we do is we work with companies to look into their legacy systems. And this is an example that we managed to, it's just an exploration of an open source project, just to see how it would look like. But typically they kind of all look like this. And during these explorations, we essentially enhance our ability to read by actually creating little tools that are highly specific for the task that we want to go and answer, kinds of questions that we want to get answered. So in this specific system, the challenge was to go and reason about feature toggles, right? So you can say, well, okay, what are feature toggles? What's so big about them, right? In this case, you have hundreds of feature toggles, and they are used in many places in the system. And you can have all sorts of interesting things about the feature toggles, but one of them is, for example, if a feature toggle is used in one place, and then defined in one place, but then used in another one, there's a dependency between those two things. And that's exactly what you're seeing here. Here we see some top level components in the system, but more interesting here, we see only the dependencies that are produced by the feature toggles. And again, like this is interesting. For example, if you're in a scenario where you want to split your system into little pieces and deploy them in different places, right? You're going to look for dependencies and you're going to look for cycles. Um, but, uh, but some dependencies are hard to see. So for example, here, if I click on one of these arrows, right, I can see the place where a certain usage of a toggle happens. So it's in this specific place, and I can go and see the source code. Now, in this case, we are, let's take another one, like here. Here we're seeing, this is actually Python, so it's no longer Smalltalk. And for this purpose, we are using a Python parser, but more interesting, in order to reason about something like this, right, setting something, you need to go and understand the semantics of the library that you're going to reason about, which means that without understanding that library, you can't build a tool because there's nobody that you need to go, you need those semantics. But the interesting thing here is that the library is built, is specific to the system, which means that if you want to go and build a picture like this, you're going to need to build a custom tool, a tool that you can build after you know what the semantics you're interested in are. And that's one of the application areas in which we're using Glamorous Toolkit for. We're using it in all sorts of other situations as well. And all of our projects, as I was saying, so we are a consulting company, but at the same time, all of those consulting projects are also actually a validation of the fact that it is possible to approach a very large variety of problems with the same kind of development experience. And the reason why we are kind of bullish on just using the same tools and same techniques over and over again is literally because we want to be sure that the theory works. The theory works in practice. Now, of course, to make this one work is not only, it's to make this idea usable outside of the scope of Smalltalk and outside of the scope of some, let's say, targeted kinds of interventions into a system. We need to, it's not enough just to look at the reading part. So here we have a use case, which is specifically about how do I go and reason about an existing system. We also want to go towards how do I, how do I cover the whole life cycle? And that's the reason why Glamorous Toolkit isn't necessarily a small, or we don't see Glamorous Toolkit as a Smalltalk environment. We see it as underneath as being also a language workbench. So for example, for the Python, to parse the Python code that you saw before, we have this parser here. And of course, I can look at it like this. That's the code that was generated by SMAC. So SMAC is the library that we're using for parsing. But it's much more interesting to actually look at the definition of the. It's much more interesting to, instead of looking at those kinds of indexes that they are hard to digest in isolation. It's much more interesting to look at something like this, which is what the definition of the grammar. And the interesting thing here is that we're consuming this grammar in the same place where we're consuming, a normal Smalltalk code. And the reason we're able to do it is because the coder, the interface that we are using here is actually just instantiated for Smalltalk, but it is not specific necessarily for Smalltalk only. So that's what we're saying, that the goal here is to build a language workbench where we can accommodate all sorts of different kinds of representations. But so this is what we've been doing for a while. But over the last year, we've done something else. And this something else goes towards, we wanted to focus more on the narratives part. The question is, like, what kind of narratives can we construct? So we were building these kinds of views. We had some sort of live documents, but it was not everything was kind of fitting together. But we think that we have now advanced our understanding in this field quite a bit, and we have introduced a new component into the environment that actually replaces a couple of other components. And this one is called Lepiter. And Lepiter is a moldable knowledge platform. So when you're getting Glamorous Toolkit, you already get a knowledge platform. You can think of it like a wiki, basically. And so let's take a look at it. And that's basically what you see here, right? You can take notes, for example. And the simplest thing that you can possibly do is just take notes. So this is a note. And I can have multiple of these. This is another note. I can also nest them. This is a nested note. But then I can also make, create links. This is a link to, and then here I get some definition, like some, I'm going to get here a completion. And interesting enough that this is a link to the page in which that actually holds the notes to my current talk. So if I'm going to click on this, you're going to see that this is my slideshow, and these are the instructions that I took to actually load the code. And then you can also see that there are lots of other, maybe a couple of other links in there. And so the other thing here we see, okay, look at this one. This page here has a reference to it, right? So we can take a look at it and says, okay, yeah, it comes from this page, what's in a note. So this is this is what you would expect from something that you could link them together. But of course, we're in a moldable development environment, and moldable means first and foremost, it's programmable and it's extensible in many ways, or in ways that are unpredictable for us as authors. So there are quite a number of things in which a number of ways in which you can extend this space, but I'm going to show you a couple of them. So I can say this is a link to a class. So for example, here I'm going to say I'm opening two curly brackets, and I'm going to say, okay, that's a completion here. So I got the first level was a completion for the annotations, right? This is what you would expect. You have a language, can be extended in, you have some predicates there, you're going to get some completion there, right? And then in there, we have the same kind of level, seems like we can say, okay, the name of it. But there's something interesting happens here. Because as I'm inside the name attributes, the completion now goes and searches in a completely different space. It actually searches for classes in my Smalltalk image. And that's kind of interesting because it hints to this idea that we want to have a completion is in a language workbench. Completion is a service that you just want to instantiate in different ways. It's not something that is hard-coded in just one way. So that's why we can just do something like this. And of course, then we can do, as soon as we have a link, for example, to the class, right? Notice how the annotations, they appear and disappears as the cursor goes, which means, they have these clunky interfaces where the edit and the views, they're separate and you have to think. And we don't like to, like when a computer should do something, put some things together, we want to allow the computer to do that rather than forcing ourselves to do it. So, and this is a reasonably difficult problem, but it's built in over here. Then of course, like if I click on, for example, on this class, I'm going to go into I'm going to just browse the class, right? So I'm just going to look into the code of that class. So I was into my notes, and all of a sudden, boom, I'm in the class. I'm in a system browser, basically, encoder. And if I now want to get the orientation and just be in that environment and orient myself in the absolute coordinates of the image, then I can just maximize things, and then I can start to see packages and classes and so on. But it's not necessary to do it because the interface is also allows me just to treat this class in isolation. Was there a question? Okay, so something else that we can do here is, you notice before I was talking about examples. So we can do something like this. This is a link to an example. And then here I'm going to say I want example. And then in there, this one is slightly more complicated. So on the one hand, I have name. And here I only, I will, let's see if we can find one. Let's say baseline of, and in this case, we're going to say baseline of G toolkit. And in here, in the class, there's another one. And what's interesting here is that I'm inside a class, right? So I'm 2 levels deep into my completion, right? And but there I expect to have the completion show me just methods. And in this case, yeah, it shows me just the method. It's the simplest possible example you can possibly get, which means just returns something, just return yourself basically there. But once you do that, right, we can go and execute this. And if I execute this, I get an inspector. And in the inspector, I could actually just go and build this visualization. And then, but then sometimes I don't necessarily want to see the code. So when I say I don't want the code, then maybe I'm just going to sheet this one. But then sometimes I just want just a single visualization or a view in this inspector. So here I have this view that I kind of like. And I'm going to click on this just to see what's the view name for. So I alt-clicked on this. I alt-clicked on the view tab, and I get to the coder basically of a method. And I can see the case is GTMap4, which means that now if I go into my annotation over here, I can say, I want to say the preview, show, isn't it? Preview, show. Oh, I forgot what it is. Oops. Preview. Oh. There is something wrong in the preview show equals this one. And then basically here, we're only going to get this view. That's it. There's nothing else. So what's interesting in this situation is that basically, normally we have other kinds of examples like you saw before with the editors and so. What's nice about this is once I have an example, I can quickly piece together a documentation which is live, and that does not copy anything. There's no copying of pictures. There's no copying of code. You're simply embedding it over here. But the same thing, right? This is what happens at the level of the text, right? So here we just saw a number of annotations with which I can put things together in the same way. So another one is, and this is kind of more interesting at the level of what we can do at the level of completion. So this is a to-do, and then I'm going to say here, I want a to-do in this case. And the to-do has a label, give the new case talk, which is kind of okay. I'm gonna delete this. I'm not sure why. Okay, something is not working here. Okay. Label equals like this. And then, so I get this completion. And as I type on the completion, right, I can, for example, click on the completion and then it inserts something over here, right? I can toggle it off and on and it will insert or remove something. But I can also equally just say I want to pick another date. So I triggered the completion, but in this case, the completion not only shows me something that is contextual, the form in which it shows it to me is also new. And these are generic engines that can be just constructed in many, and combined in many, different forms. Because everything you're seeing here, these are all plugins that you can just put into the, or combine with the rest of the environment. All of these annotations are completely programmable from the outside. But then, of course, we don't just want to have, like we can see here that we have text indeed, but they are all embedded into these little pieces here. We call these snippets. And these snippets are their own, right? So there is a textual snippet, which comes with its compositional, it has a language that can be composed. But then we have all sorts of other things. For example, here, we can have just a normal Smalltalk piece of code. So one that we like to show is this one. So this is a query over the system, and shows as a filter with the amount of views that are present in the current image. So if we're now going to look here, we have 3,000 views. This is not just a default image. In the default image, we have close to 2,000. But it kind of gives you an idea of the amount of extensions that are interesting or possible when we're working in this moldable way. So, but here again, like I was just having some notes, and I was just having an idea, and I wanted to express that idea through a piece of code, and that's what I wanted to embed in there. The same way, we can have other kinds of other types of snippets. So if I'm going here, I can say I want an example. And in this case, I kind of get more of a WYSIWYG thing. I just copied the example that I saw before. And as I'm pasting it here, I'm going to have that example just printed in here. So now I have it it's not embedded in the rest of the piece of text. It's just in a separate snippet. So again, like we can compose pages like this in many ways. And again, those snippets too are not fixed points. They can be extended in many different ways. So one way in which we want to emphasize the programmability is that we want you, where would you program? So many environments say that they're programmable, they're extensible in some form, but there's little emphasis on how are you going to program it. And of course, like being in a Smalltalk environment, there's a very rich inheritance that we rely on because the environment is already there, and so it's very easy for us to pick what is interesting in Smalltalk and then start combining with these other kinds of problems, such as, for example, how would you work with your knowledge? So one way to look at things, let's say, when you look at knowledge management platforms today, they will advertise a feature like the graph of the pages. So here's a page, and in this page, we have a couple of snippets. Now, the interesting thing about the snippets is that here I have a reserved word. So this snippet is a new is a reserved variable, and this snippet, if I inspect that, I'm going to go to the object behind this specific snippet. And now it's interesting, this object is not the UI object, it's the domain object, the one that is part of the knowledge base, right? So from this one, I can go to the database, and from there I can go and ask the pages. And if I do this, I'm going to go and do exactly that. Interesting enough, you can also do, there's a little toggle here at the top, so this is my default editor, but I can also change that one. And I'm going to go into the inspector over the object that is now the page, the sum of the snippets. And again, like here, we can go and play with various things. And one of the things you saw is that we have links to other pages, so we can start to see those kinds of links over here. But sometimes this is interesting, sometimes it's not, right? As I was saying, this is kind of featured as a feature. We just think this is something that you could just extend anytime you might be interested in. So, but if we have something like this, how would you do it? So here's a little snippet here using Mondrian. It's a visualization engine. that exists and ships with Glamorous Toolkit. And so given these pages variable over here, it's just a collection, right? I'm going to say I want to go and render everything here. So I'm going to see, okay, look, I see that I have my graph of pages. By default, it looks like this. It's kind of interesting, but it's kind of this, I noticed that there's like this weird thing here that links to everything else. And the question is, what exactly is this? Well, this is, if I now click on this, this is not just a rectangle, this is the actual page. And I can see, oh, look, there's a page which is called Glamorous Toolkit book that is at the center of everything. And if I look at it, it kind of looks like a, like a table of contents over here. So if I go now back, indeed, if I maximize my page, I can see that I'm in the context of a larger database, which in fact, this is the book that we are shipping with Glamorous Toolkit to describe Glamorous Toolkit. And but now that I know that I have this, like at the top of it, there's Glamorous Toolkit book, which holds the table of contents. But now that I know that the Glamorous Toolkit book is not really an interesting piece of content, it's technically interesting because it holds all the table of contents, but it's not interesting if I want to see how things are connected. I can just remove it from the list of pages. So I used to have, if I'm inspecting this one, I have 159 pages in our book. And if I reject this one, I'm going to have 158 of them. And then again, I can go now back and apply the same visualization, and boom, I have a completely different perspective. It's a new view. So technically, it's the same view, but just by changing it a little bit and contextualizing it, I extract a new kind of value. And I can continue doing these kinds of things. So for example, here I'm extending the same visualization. So rather than showing everything in black, I'm going to highlight in red the pages that have Lepiter in their name. And again, like I can click there and go on and investigate those. So this is how we are seeing, right? So as soon as there are no features in our environment, there are only operators that can be combined in many, many different ways. And so we've added a new set of operators that are about editing and managing content, but everything else that exists, so for example, the way we visualize, the inspectors that you see here on the right-hand side, they existed there since a long time, but they are very much combinable with this new ability, and it leads to a new kind of an environment. There are new properties that emerge that are difficult to achieve otherwise.
Tudor,
yes.
Where you've got the code that shows how to create these visualizations, if you don't want to see that, if you just want to read the narrative, and maybe it's like a hyperlink that like just shows you the code, are you able to like hide that? So, but like, like when you say now let's click on the nodes, I'm just wondering if like what you've collapsed could be the hyperlink, and clicking on the hyperlink just shows you the context, but then you could expand the hyperlink to see the code. I'm just wondering if you go that extra kind of level of hiding at all.
Oh yeah, we didn't implement it in this one. We had it in a previous version. It's going to come back most likely. Yeah, so collapsing larger things and summarizing those, absolutely relevant. And,
if you don't want to see how you did it, I just want to read the documentation traditionally. I can do it that way. But if I want to see how did they generate this, then I could expand it and see the. Okay, that's not. Yeah, that's neat.
But there's one other thing that we were not quite content with when it comes to representing knowledge, because that's what the knowledge platform should be about. And one of the things that we saw is that, well, not text is very rich, but it's kind of limited at a certain point. So we wanted to explore how do we represent other kinds of knowledge. For example, here we have a wordly map that actually is a wordly map about moldable development. So it's this idea, right, in moldable development is that eventually you have a decision to make about a specific problem. And in most cases, people are going to approach this one through manual views that are put together based on manual inspection. And these manual inspections happen manually because of rigid tools. And we don't want to have manual views, because manual views, they only, they represent what we believe the system to be. They don't necessarily represent the system, and we want to have the conversation with our system rather than with our thoughts. Our thoughts are also interesting to explore, but having the feedback from the system is very important. So, in order to generate these views, we want to have this specific coding here. Now, of course, this is a diagrammatic way of representing knowledge too, right? So here, for example, we have a link. I can go and preview this one. This is the software assessment page. And, but also here, like in some of these nodes, if I right click on those, I can see, oh, look at that. There's a, there's a link to software assessment as well from here. So I can click on this one and I can get to this page. And now when I look back, the preview knows to say, well, this one comes from this textual thing, it's shown like this, but this one comes from a visual representation, which means that we wanted to have the way, the engine of linking things, we wanted it to be agnostic of the language in which the knowledge was represented, basically. So, right, it can still, react to things, but these are not hard coded. So we wanted to reach a place where we have the least amount of hard coded decisions into the core engines to just allow people to build things on top of it. And we've built just enough of different samples to provide people enough examples so that they can do. They can go and build what they wish on top of that. Okay, so finally, I mentioned that our goal is to go beyond the Smalltalk environment. And here is here's an example of actually using JavaScript together with Faro. And in this one, we have going to take a yarn file, which shows basically defines the dependencies of a project, can define the dependency of a project, in this case of D3, which is a visualization engine in JavaScript. And now we're going to say, you can start an application. And in this case, this snippet here, this is not Smalltalk. This is Faro. This is not Smalltalk. This is JavaScript. And it's connected to a local application that I already set up. It has this module installed, the yarn package log file. So now I just said, I have this log file content and I pasted it here. And now I get back a log file JSON string, which is another variable. And what I'm going to do here is I'm just going to say, okay, now I have some JSON and I'm going to parse that one because I have a parser for that. So I see this dictionary, maybe I'm going to massage a little bit this one just to see which projects exist and which edges are between those. If I have those, I can of course go and map those. But the interesting part here is that we had some piece of code was in Smalltalk. There were some variables defined there. Then we can transmit those variables into a JavaScript, let it do the work. We get some variables back bound with objects from JavaScript, but then in this case, we can take those and then use them again in Faro. And we have these kind of bindings for Python and Gemstone and also remote Faro, of course. So you can start to see how, like we're reaching out to external environments for executing code as well. Okay, so the question is here, what can we use it for, right? So I showed you here a couple of examples. By the way, this one is something you can find in the page, so it's available out of the box in the book of GT. But there are a couple of things that we are using those. As I was saying, in our projects, we work with external companies, and we actually work with two kinds of companies. On the one hand, we work with companies that are in some sort of a crisis, typically related to some sort of legacy system, Legacy system can range from just being in some old language, a combination of languages. Sometimes it's just a data pipeline. Sometimes it's just some more complicated types of runtimes that they somehow need to go and understand, typically for some purpose, the purpose of some modification, some change. But on the other hand, we work with companies that are seeking a competitive advantage. And we do believe that enabling people to have intelligible conversations about the inside of software systems is going to be likely the most important competitive advantage for the next decade. And so here we have such an example. This is a project that we are working on together with with a company called Poly, whose goal is to create a new kind of data a new data economy that is centered around privacy. So among the different things that we work on are reverse engineering data that other corporations have about you or about us. So here, for example, we have Facebook. And the interesting thing here is that the thing that you're seeing here is actually not the real data, is synthetic data. So we went all the way to go and understanding this undescribed data structures. You can go into Facebook, for example, you can download your data, and you get this interesting blob of JSONs, basically. But there's no description about them. And so we went to go and understood what was in there. But then what was interesting is that we created also a generator of different kinds of Facebook profiles once we understood the number of them. So here you have one of them, and in this case, we actually can generate the actual files on the system. And here we have, for example, the reactions. So these are the kinds of data that, for example, Facebook has about you. And we're using here, the only thing we're doing is that we're just having these kind of liberator pages and then combining them with inspectors with many different views to look into this. So here we have the reactions. And then, for example, okay, I want to see what did I like? I liked a lot of things. And but when I'm gonna that's not the most interesting thing. Let's see. When I'm gonna see them, yeah, these are all Facebook reactions. So we can see how how we'd accumulated over time. But let's see if we have here, for example, messages here. So these are the messages, Facebook Messenger data. And let's pick something, I don't know, for example, from 2021. And these ones, of course, these are all generated messages over here. But here what you're seeing is that when the messages happened in this case. So if I click now on this, I'm going to only see, instead of seeing all of those from 2020, I'm going to see all of those that happened at 15 or 16 o'clock. And then I can say, oh, I want to group them by thread. And then, of course, and then I'm going to say, which ones are these? And then we're going to say, we're going to say, when did this happen? So here I said, I started from a specific time. Then I say, I want just to say, when did I talk with this person, for example? And then how did this evolve over time? But then I can do it the other way around. I can say, I can start, for example, 2020. I can say, group them by thread. I'm going to pick somebody. And then we're going to say, I'm going to see when this happened. Notice how the same views, I use exactly the same views. This is a view, this is another one, this is another one. But by just changing the order in which I apply those views on the data, I form different sentences. So here it says, when do I talk with this person? When did I talk with this person in 2020? And then in the previous one was when at 16 o'clock, in which years did I talk with this person? Again, sometimes they make sense, sometimes they don't necessarily. But what's interesting here is that these views, right? We saw that we have like 3,000 views in this installation over here. But the views, they are not just usable in isolation. The interesting thing about them is that we can weave them together in larger narratives. And so some narratives can look like this, right? So it's just a page. Some narratives are more transient, and I'm just going to dive into something to formulate the reasoning. And of course, when I don't have a view, I'm going to go and create one just for the specific purpose of telling a story, and of just the one story. And sometimes those views might be reusable, sometimes not. But the interesting thing at the end is that we are not just creating thousands of narratives. We are creating, because all of these views are combinable. You are literally, every time you're going to build a view, you're going to explode the space. So in this specific, for example, image, we can likely create millions of narratives. And that is the kind of behavior change that we want to reach with the kind of development experience that we want to put together. So there are other kinds of things that we see here. This is kind of an interesting one. These are the all Facebook events, but yeah, let's not activity on inside. For example, this is the activity that Facebook has about you when you're inside Facebook or outside of Facebook. And if I'm going to pick one of these, I'm going to say when these events happen, and I can see, look, I can saw an ad, and eventually I had a page view, which of course maybe there's a correlation there. So these are the types of things that we can explore, right? And then the only thing we've done here, right? We started from something that is just a development environment for just playing with, you know, and eventually initially small code or some code. Then we added these little nodes, and all of a sudden, by making the nodes composable and easily composable, we are now exploding the amounts of things that we can express with just the same environment. And the interesting thing here is, again, is that we can learn this whole work has value if it is possible to learn once and then use many, many times over. And it is not about the programming language in this specific case. We are focused on the environment because we think that this is the multiplier. Okay, and maybe a completely different kind of a use case, right? So we went into a use case where we had some, in that case, it was basically data reverse engineering. But here's another one. So I'm using Twitter. And one of the things that I like to do with Twitter is to write threads. But if I'm going to use the default Twitter interface, the default Twitter interface wants me to act immediately, so I can handle one thread easily or somewhat easily. But it's kind of difficult to keep track of multiple of them. But then, of course, here I have, I don't want that. I want, if I have a noting system, if I have a knowledge management system, I don't want to go and create knowledge or representation of knowledge in the terms under which I'm going to interact or create. I want to be able to control. So here what you're seeing is that this is a little snippet, a query over my own knowledge base, which actually shows me, gives me all the pages that have open threads from Twitter. So for example, there's one here from the current talk. So I'm gonna close these ones. There's a tweet that I just tweeted 1 hour ago. And there's another one here that I didn't tweet yet. And see, I'm just gonna say, am I tweeting during the talk from Glamorous Toolkit? And I just tweeted this. So I can go on Twitter and you can find it because it's right there. So I was inside my my own, something that appears like a development environment, but I just composed a tweet, because this tweet is nothing but a snippet, which is programmable. In this case, it actually connects to a server and a relay server that and then connects afterwards to Twitter. So this is the extent to which we go, right? Normally, when we think about tools today, people think of in terms of verticals, right? You have these walls in between, and they have to jump from, you're going to say, people are going to decompose activities by tools. And of course, the idea of Smalltalk has always been that apps were a terrible idea. So that's exactly what we try to see here. But the question is, how do you increase the abstraction level such that this composability, the language, how do we enable people to create these kinds of experiences that are reasonably meaningful, but at reasonably low amount of effort? And that's why we are seeing not so much the programming language as being the core, but the environment as being the language. So, of course, the other kinds of things there are also other technical things that we're doing, not only the conceptual parts. So we have now a Git integration, which is directly native in Glamorous Toolkit. And of course, there's kind of things that you would expect. So you can see this is a commit, and you can we can go into it and see a diff of it. But more interesting here are the other kinds of opportunities that we have. So for example, here it knows, oh, look at that. There is a baseline in this repository. And I can go and browse this one, and I'm going to go in and I see the code that I have right there. And then if I change this one, if I change the code, it immediately recognizes that there is a code that was changed, and I can just go from there. And again, the same thing happens at the level of Lepeter. So we can have now Lepeter databases integrated in and committable in the same from the same tool. We don't have to now, we don't have to go to the command line. So because otherwise this wouldn't be an integration. So this is like one of these technical details that are nice to have. There are other kinds of more interesting things, and I'm going to go through them rather quickly. One of the focuses we had was, how do we make it so that the environment isn't slow regardless of what you're going to hit? So, like classically, a Smalltalk environment is kind of built around collections. And this kind of works when the collections are reasonably small, but when you have larger pieces of data, then all of a sudden they don't work. And so here we have, we built a new infrastructure for streams, futures, and promises. And so one of the applications are they go into, for example, for querying. So here I have a simple query which says, give me all the methods that for which the class name matches this object. So when I do this, I'm getting some result. In this case, it's not very large result, so it's just 3,400 methods that match this description. But and still, the result came reasonably fast, and that's because we are not showing everything here. In fact, the whole computation stopped as soon as the screen was filled. So you can see here, if you take a look at the scroll bar over here, right, as we scroll down, it understands that there are more and more, and the computation happens. Also here, these little triangles which show, oh, look, this one is override. Oh, this method overrides another one, is also lazy, actually, and takes, it's computed after we're scrolling. So if I scroll, only afterwards, this one comes. So it's all based on the same engine. But this one is a much more, it will return us a much more results. And still, if I execute this, I basically get instantaneous feedback, and the image doesn't stop. And so same thing is, we're using it also for browsing. For example, if I look at a large class and I inspect this, and I look at, I look at the methods, this is quite fast here in the inspector, but then equally, if I just expand the class, I can look at the class right there, even if it has a few thousand methods actually. So it is all reasonably fast. Now, The other thing, so this was one kind of limitation that we wanted to overcome in a typical Smalltalk system. Another kind of limitation, and so before that, this is another application of promises. So here we have a migrate form. Okay, this one doesn't work at the moment. So another limitation we wanted to overcome was to escape the one processor limitation, of course. So we have, this is not a finished piece of work, but it's very close. But it's already demoable at a technical level. So here I have a little snippet, and this one is, as I was saying, this is a more technical thing. And I'm going to say from this image, I want to start 2 other images. And I'm going to run this. And this image has here 2 gigabytes. And now I wanted to start here 2 workers, and they started. So this one just got updated now. So there are 2 other processors, right? Two other, images and virtual machines instances running in parallel to this one. And what's interesting about this is about these ones is that they have they did not copy, nothing got copied on disk. We're literally starting it everything from just by what existed on disk. So it's everything happens. There's no writing on disk at all. And the other interesting thing about these specific images that we just started here, we can start all sorts of combinations. But in this case, we started them with something called code sync. So these images are actually synced. They are syncing code transparently from this main image to the worker images. So it's we can one of the applications for this is to, for example, delegate tedious work such as examples. So or running examples or running tests. So here we have such a case. We have here in baseline of block, we have a number of examples. If we look here, we have a few hundred examples. And what we would like to do here would be to run all of these examples, but to run them remotely. So now I'm gonna create here a job, and the job is basically is gonna split all of these examples by classes. So I have 153 tasks in this job, and I can see how the results are being now distributed to these other workers. They're doing their job, and the results are coming back here, and then it tells me it's completed over here. And in the meantime, the image was completely live, right? So there's no, it wasn't stuck. We can also take a look more specifically at this one. So we have 626 specific tests that were executed, and they were all successful. So I have here one of these examples that we ran, and I can just say, well, let's change one of these assertions. So here I have some assertion equals to 2.0, and I'm saving this one. And I save this one locally in this current image. And so what I will do now is the workers are still working there. We didn't stop them. And I'm just going to say, run these ones again. So I had my 153 of them. And so the workers are totally different image. And now we gave them the tests or the examples to run. Let's wait until this one finishes. It lasts about 20 seconds or so. In this case, 19 seconds. And now if I'm going to look at this, we see, okay, one of them failed, right? And so it's kind of interesting here, because when you look at saying, oh, it failed, so how did it fail? We're going to say, well, I can actually go and browse the code that failed. And when I look at this, I actually also get the assertion here. So of course, this is an assertion that was in this case was, I'm just looking at the string at the moment, but we have the possibility of actually synchronizing or streaming actual objects if we want to. We just sometimes not always want to for performance reasons, but it's possible to enable that one as well. So that's basically what we have. And again, like we can change this one back here, and we're gonna give this one give the same job again, and it will become green. So what I've showed you today were a couple of things. First, we started from what Glamorous Toolkit, what we knew, what we communicated already about Glamorous Toolkit is being a development environment surrounded around, starting from small talk. So you can see here, all were successful, none of them failed. But then we introduced the Lepiter, which is a new component, which actually replaces what used to be called a workspace or a playground, but it also replaces what another component that we had, which was called Documenter, for just writing things. So they are all in one, but they're a little bit more because they're now we have this programmable knowledge management, and everything. By the way, all of that knowledge is completely stored on disk, and you can publish it on Git. You can use other services that we're working on as well to share with others, but in the simplest form, everything is private, and you're going to share whatever you want in whatever form you want, and everything is programmable. And by doing that, we essentially increase the space of things that we can express quite significantly. And then the other kinds of things that we worked on were, how do we escape the confinement of a single image running on top of a single processor? So of course, we have the connections now to some other external environments, such as JavaScript, Python, Gemstone. But at the same time, we wanted to have also this ability to run remote jobs. And here you're actually having a full, there's a queue in between. Everything happens asynchronously. The responses happen asynchronously. Workers are polling. They are not they are not being pushed into. You can spawn as many workers as you want. We tested this on installations with thousands of workers, and it works. And everything is is implemented in Smalltalk. So this is one way. And then of course, because now we're going into this kind of working with data that might come from somewhere else, streaming was important, and handling or having at the core or capturing at the core of the environment the ability of reasoning about behavior that or results that will happen in the future. These were important pieces, and now we've started to have those as well. So this was an update of what we've been busy with for the last year and a bit. I'd be happy to hear more questions.
Okay, if anyone's got any questions, just unmute yourself and ask away.
So when you have those workers running in the last example, you change the test method in your main image. Do the worker images automatically move those changes forward? Is that how it worked?
Yeah, so these are, so let's take a quick, maybe a slightly deeper look here in the runner. So I can see I have here 2 workers, and I can see those here. And these workers, they have on the one hand, they are connected. There is a special service, which is called code synced. So this you can think of it like a special kind of channel of communication. And when this one is true, then all the main image will put the code changes into a queue, and the workers will just take them from there.
What about like duets? Those don't go through?
No. So in this case, we didn't. For this case, no. But those kinds of things are possible. But of course, we can actually open here a connection to these ones. So I can say, I don't know, I have to put here some some port that doesn't exist. And I'm now opening, now I have an inspector here over the remote worker. And then here I can actually, if I am going to do something here, it will, I execute something remotely. It's not locally.
Cool.
For example, something like this, it will tell me there's one of them. So this is something like there's a worker instance on this worker image.
And can those workers be on separate machines, like even on cloud machines somewhere, anywhere?
Right, as I was saying, we tried with more than 1,000, and they were not on our local machine.
Very nice, cool.
And this again, like there's zero other framework here, but the difficulty, right? We have two kinds of for this type of engine. There are two types of use cases. One is the local development, and where you have your machine and you want to make the most out of it. So here, for example, we want to run our examples all the time, because why not? If it's possible, we should be able to do it. But then sometimes you're in the other scenario where everything else is remote and where you do need to actually copy things over. But when you're on the local machine, one difficulty here was, well, how do you make the image not write anything on disk? Specifically about changes, right? Because you saw here, we want to be able to replay all changes, but the image on the other side has to know that the new changes appeared. And the way we handle this was actually that image is reading from the changes from disk only up to the moment in which at which the image was saved. All other changes that are replayed on that worker image actually happen in memory. So we have a kind of a hybrid type of a stream that knows how to read from one place and then continue reading from the other place to basically make it look like it's seamless. And so the goal here was to have almost like as little latency as possible to spawn something locally, so that we can just do kinds of things like this. So another obvious application, for example, is search or so, but I'm sure people will find others.
Thanks. I think we got Ofrey. I'm not sure how to pronounce your name. Sorry. Would like to ask. They would like to ask a question.
Okay. Yeah, Ofrey is fine. So Tudor, thanks for Glamorous. I think that is like a really promising environment, and also I think that despite of being like focused on trying to, let's say, modify or transform the developer experience, it could modify a lot of experiences. So I came from the hacktivism and civic tech front, and I think that Glamorous has a lot of resonances with what we are doing, especially with data storytelling, like the idea that you can like amplify civic voices by putting multiple tools over there. And I think that Glamorous is a really cool toolkit to do the stuff that we were previously doing with Graphoscopia, with this tool I made. But I would like to know your opinion about like this, let's say, broader sense in which Glamorous can transform a lot of experiences beyond developers, like I don't know, journalists, activists, and these other people that came, or no, I don't know, reproducible research, for example, in science or in journalism or in hacktivism, and also about the interactions, because I think that you are like really welcoming in the chat group, in the Discord chat group, but also by experience, I think that is also a lot of, I mean, you need a lot of real-time involvement. And I know for experience also that people in journalists or in hacktivists or in other places, they will prefer less, let's say, another ways of interaction, more asynchronous, more forum related. How do you see this Glamorous toolkit in this more broader sense beyond developers? And how do you think that let's say, developer culture can interact with other cultures that have other ways of meeting and doing stuff together.
Okay, thank you for the question. So the reason we are focused on the programming experience and not on the what is perceived to be, let's say, an end user or a non-technical person is because we noticed that there's this large challenge today, which is that on the one hand, we are creating these systems very quickly, new systems. So the body of code grows non-linearly, but at the same time, we're unable to recycle old systems. And given the reach of software today, that is not sustainable. It's something we call software environmentalism. And I think we're in a crisis, and we have to. And I'm not talking about the software engineering crisis as it was, but the problem of not being able to reason about the things that we are creating. And given that those reshape everything we do, I think we should spend way more time thinking about as a group of people that are highly that are highly privileged, right? So, for example, like just in the last 2 years, this privilege was quite obvious, given that most people's lives, right, in the world have been disrupted dramatically, while we as like programmers, for example, right, they could continue working, creating value with limited inconvenience. So with that privilege, I think that comes responsibility. So I think that it's important to address this problem. I'm very convinced that we have the beginning of these conversations. I'm also very convinced that there is way more that can be done. This is our main goal, given the size at which we are currently, is to establish this field as a conversation. We think moldable development is an essential part of what software engineering should be. And like everything, like if you look into the history of software engineering, which is not very large, but it can be informative, is like all the original ideas of any idea. On the one hand, it either got distilled in some uninteresting ways, but on the other hand, it's always also possible that as the conversation grew and got more organized, new kinds of innovations were possible. So we can now produce, systems that were unimaginable just a couple of decades ago in practical terms. And that's an interesting thing. Not they were unimaginable theoretically, but we wouldn't know how to do it practically. And now we can, and at scale. And it's kind of interesting. It's very exciting from my perspective. So our first goal is to make this a subject conversation. Now, should this be just about software, or what about the rest of the conversation? And here's where I think was something that was missing. And you see, software is everything in a computer is made out of software. So if we do not get this one right, it's very hard to get anything on top of it right. And we know this from Smalltalk because this is how the personal computer idea was formed, right? It was just saying, if we have these operators, and if we pay attention to these operators, we can build extraordinary things on top of it. And for the longest time, creating something was hard. But now it no longer necessarily is hard, although it's still harder than it needs to be. But it's much cheaper than it was. But so the only other part that is left is what happens with the things we have. And this one has all sorts of consequences. You see, when software becomes both law and order, because everything becomes software, it's kind of important to understand, also from a civic perspective and from a societal perspective, it's kind of important to understand what is this, because they have to be debatable by normal humans. Today, we accept software as black boxes, and they're big black boxes. And this is not sustainable, and it's not reasonable. So I think this is one reason why I think it's important. But the other thing, if you look into more, let's say, immediate terms, like here I showed how in a development environment, we can accommodate some, you know, for example, when we were looking at this Facebook exploration, this is an exploration that happened not necessarily with technical people, it happened with domain experts, privacy domain experts. And this is another kind of, this conversation happens in the development environment. And this to me is an essential thing. I think there's many more things that could be added on top, and that we could be created and expanded in many different ways. But the essence is that if we want to ask something about how this, you know, if at some point somebody wants to say, how is this button being constructed here? They should be able to click on it and go and dive and answer that question. This is an important thing. If we want to have a conversation, a constructive conversations about this digital space, we have to be able to drill into this. I didn't invent this one. This is how it was there from the very beginning. It's just that it got lost. It unfortunately got lost along the way. So this is why we are so bullish into saying that we're starting from a development environment. I think we are addressing an important question that has to be addressed, and we need to start having a conversation about. But there's many more things to do, right? So Smalltalk wasn't created for people to create software. It was created for people to create personal experiences. So of course, there are many things to build on top of it. And the space is so large and so unexplored. I mean, it is explored, but it's explored in so uninteresting ways, right? Like all our experiences are you know, thrashed by all of these little tiny minute types of tools and experiences. And it's just so, and I think many more things can be done, but we have to relearn how do we approach this space. And I think this idea of building a language, the environment being the language, I think that's an important one. And there's still lots of research to do there, but I think it is important. And so now to the final point that from your question, which is, how do you go to a community that does not share, for example, your language, but maybe doesn't even share the way you're sharing knowledge with one another, and having an environment that in which two people that come from different backgrounds can actually have a constructive conversation, I think it's very important. But then, as you were saying, there are many other things. There are social parts that we didn't touch here at all on. They are equally interesting and equally important. But I don't know. I hope I kind of touched on this, right? So, for example, in this little thing here, how do you tweet but without being dominated by what Twitter wants you to or how Twitter wants you to think? And how do you, if I have a different behavior, if I want to have a different pattern of behavior, how do I take control of that? That's no longer a technical issue. It's more of I'm on another side, but I think it's the fact that we can express it even in super rudimentary tools. It's kind of an interesting thing. So I think, yes.
We have a couple of comments on the chat. So Graham is saying, I'm keen to take this conversation to the business modeling level. Graham, do you want to comment a little bit more about that?
Yeah, I can. I've been working for quite a few years, as Tudor knows, in the business modeling, domain modeling, enterprise modeling space, and also love and very long time Smalltalk user and enthusiast for what Fink is doing with GTools. I do think that environments like this that create these operations and combinability and moldable views are starting to build a platform where we can start to enable other conversations, where we create not just programming languages or parsing and syntax and semantics over programming languages, but modeling languages. And that's a space I'm really, really interested in and working in at the moment. So yes, I think, if we can have an environment that allows us to work with domain experts at a domain level and translate that and drill down all the way down to the code of what happens underneath to have a verifiable environment or a realization trace, I think that's very, very powerful.
I agree. So actually, one area in which we work with businesses on is literally domain discovery. So not so much verifying what has been built. Also, that one is an issue, but how do you iterate faster to learn what you should build? And that's not a technical conversation. That's very much a business conversation. It's a domain conversation, and you need to start working with people that come from completely different backgrounds. And we find ourselves with these super basic tools. And again, like this is the very beginning, in my mind, about what is possible. And we're still in a 2D, still in one window, a reasonably small screen. There's so many things that are possible, but we're kind of sticking to a simple kind of thing, just to show how far can it go. Because if this one goes far, then you can expand anytime. But how far can this go? And this one goes against this other idea of basically training skills per domain, per little boxes of knowledge. And yeah.
Yeah, I think you alluded to the tyranny of apps, where we have some super useful little apps, but they fragmented and they basically give us a broken work chain and a broken perspective, because they don't integrate, they don't link across each other, they don't let us put together an integrated workflow or a story or a narrative from end to end. And I think we've got to guard against that.
Right. And the other thing that we saw is that it's very hard, and it's typically unsound, to add computation to something that is dead. So you can add other types of artifacts on top of a sound execution environment, but you can't do the other way around. That's why going from the end user, because we've many people focus, like it's kind of interesting to look at low code, no code kind of thing. It is being advertised these days, right? They have these huge amounts of energy being spent on top of it. And we have now the opportunity of actually looking at a system that was built on top of a low code platform, and nobody knows how to change because it wasn't made for it to be read. And it's also interesting to notice that every time you have this kind of low code, no code type of offerings, you're going to find that there are services being offered specifically for kind of customizing. It's not programming, it's customizing that thing. And this makes you think, so, well, isn't that programming? Or isn't that what programming should be? And why do we have this distinction? And I think it's harmful. And it's a lot of energy being spent on the wrong problem. And because we are seeing here, right, we can have It's very high business conversations. So sometimes we are working in companies and having investment pitches to high-level VCs, for example, happening inside an inspector. There's such a rich opportunity.
Yeah, it's about ideas. It's not about code.
Yeah.
It's not about apps. It's not about functionality in an app, etc. It's about ideas, and ideas are best expressed in domain concepts. And domain concepts have properties, and they have state, and they have relationships. And so you need the core to be semantic. On the core, you can then perform all sorts of operations, and you can derive many different views that are useful to different stakeholders. And we really need what you're doing, and then we need to scale it up to make it shareable and collaborative and all the rest of it.
Yeah, clearly.
Yeah.
So it seems like Glamorous was built as a data modeling and data exploration tool that was domain neutral. It's just that the first domain you started using it on was Smalltalk code, and it expanded to other code domains. But it seems like you tried to keep the core of Glamorous as domain neutral as possible, leveraging more on specialization, plugins, extension. Is that correct? Or?
Well, so the first problem that we want to solve is enabling normal humans having conversations about the inside of systems. We think this is a fundamental problem that is basically threatening the human race today. And I think we need to address this one. I'd be content to just address that one. It just so happens that along this, the way we are validating this approach is saying, well, we spent the most amount of time just thinking, what can we do differently with a single object? Just a single object. And why a single object? It's because to change large patterns, right? Like if you want to solve like large problems, you need a lot of energy. Unless, of course, you find a way to say, well, what if I can just change a little bit and then affect large things? And interesting, in software, we have this property, like software tends to be, tends to have fractal-like properties, which means that problems that you can see at larger scale, you also see at smaller scale. So if you want to change the large things, you have to change the smallest thing. And that's why we focus so much on the object. The reason we started from Smalltalk is because I don't think we would have been able to practically advance anything in another environment today, simply because we would have not been able to think like this. There were so many things that took us by surprise. For example, one of the things is that we noticed, and we looked into our, the way we work is we're everybody is in the team, everybody's remote, and everything is asynchronous by default. Everybody works on whatever they want. The question is, how do we build something that is meaningful? And I didn't know. And I still not sure, but I think I have an idea, or we think we have an idea. And the idea is, if you look at an organization as being nodes made out of async, like actors with own volition. Then you can think of it like the company or the organization as being a distributed system. And of course, the key problem in the distributed system is how do nodes get in sync eventually, right? And then you can have people come in sync, or nodes come in sync by forcing some synchronization, or you can rely on eventual consistency. Most organizations today, they rely on, for example, meetings, and a meeting is a synchronization mechanism. But we know that if you want to build really scalable systems and high performance systems, either you go, fully synchronous, fully sequential, or you go on the other extreme. And so we wanted to go on the other extreme. But the problem there is, and this was the surprising thing, the problem there is that if the cost of communication is high, it's very hard to have a performant asynchronous system. But if you can compress communication, let's say an order of magnitude, then you have a new opportunity that you didn't exist before. And the surprising thing for us was that the most interesting side effect of moldable development is the compression of communication. When we have a view like this, we can literally spot problems in seconds. And it's really, really crazy how a simple picture can help somebody says, oh, look at this one. And boom, it takes nothing. And it can happen completely asynchronously. And because of that, lots of energy can be focused on something else. And I'm very much convinced that there's a lot of waste happening on how people communicate. So you asked us, where did it come from? We started in Smalltalk because I don't think we would have been able to think so quickly. And in fact, I mean, we have a company, so we also have to produce value, which is, people measure us by what we can do in months typically, or weeks. So we have to be able to deliver that, which means that it needs to be an actual system. But on the other hand, we also want to be able to learn. And there were so many things that we didn't know we would learn along the last decade and a half and a bit, that we would have most likely not been able to do it outside of Smalltalk. So this is why we started from Smalltalk, actually. Now that we know how things are, does it necessarily have to be Smalltalk in the current form? I think the answer to that one is not necessarily, but still, and I'm still sure that there are many more things to learn on top. But some of those things that we need to learn, for example, when it comes to communication, you need sometimes speed matters. So can we get it technically from the current infrastructure, or do we need to go somewhere else to get it? So the environment has to be conducive to the kinds of learning that you want to do. And so far, Smalltalk was really, really great. But yeah, does this answer the question?
Kind of. You're speaking to Smalltalk as the implementation language of the tool, which I totally understand. I was asking more about the target of the tool. I mean, you could have chosen the first target to facilitate understanding and narratives of, I don't know, music or any domain. But it seems like the first target of the tool was understanding Smalltalk code as well.
The first thing was actually understanding other systems, not Smalltalk systems. It just so happens that as we were developing a development environment, Glamorous Toolkit is a case study for us. It's a case study that we have to live with all the time. But the first.
So when you say other systems, do you mean other Smalltalk systems or,
no,
or other non-Smalltalk systems? Other
arbitrary.
non-software.
Right. So today, for example, we work with. We don't even, like when a company says, oh, we have some legacy system or systems, we don't even ask what language they are, because they typically don't know, or if they think they know it, they're often wrong. So most of the time we find ourselves actually reverse engineering the language first, or languages, and then building up the tools on top of it, almost live. So we literally talk about a variety of possible languages that we have interacted with. Does this make sense?
Yes.
Could I jump in and ask a somewhat related question, which is, sure, how to get started with a problem? So for example, if you've got a business problem and maybe it's in a language that GT doesn't support. I'm working with a group that's got PHP, but I think PHP is not the important thing. I think it's an accounting business problem, and there was something around versioning of templates that was interesting. Would you sort of model that in Smalltalk code, like to build one of these diagrams to explore it? Do you typically find that you create the Smalltalk classes to sort of simulate the problem to help people visualize it, and then from that build something, or would you parse something from the system itself, or what's the?
Well, typically, so if the system exists and you want to reason about what exists, then you're going to ingest whatever the form of the whenever the data presents to you. So sometimes it's source code, sometimes it's data, sometimes it's configuration, sometimes it's something. And yeah, we're gonna build whatever is needed to ingest that data. Once you have the data and once you do something else, then you're in a in a place where you want to model something new, and that's when you might want to use small font. But again, this is an like if this thing is to work, it needs to solve economically a problem. Today, people do not, the cost of not knowing the answer to something is not considered a liability. It's going to change reasonably soon. Like this, I mean, we can literally, like if we can go in a matter of sometimes days, or you know, and we compete with a team that is working on a system for, let's say, a decade, and you can within days or weeks start to say new things that the people that worked on it for decades couldn't say. That's a dramatic, this is an unreasonable situation, and it only exists not because people are smarter or not, because people that are building those and keeping those in their brain, for me, this is a wonder of, you know, like of human ability. So many and so much to be able to handle so many details and still have a system that works without views into the system. For me, this is something that I can't comprehend. I don't know how people do it exactly. But if what we do is actually possible, it doesn't say, oh yeah, let's go and work with Think. That's not the conclusion that people should draw. The people should say, this is possible, hence it's possibly in other places. The reason we are doing a very large variety of case studies is literally to show this is how wide the space can be covered with the same investment. So now it's up to people to say, well, do you want to invest in it or not? I'll go back to, 15 years ago to DevOps. Did everybody jump onto the public cloud and deploy things 50 times a day? No, right? But some did, and they had huge competitive advantage over everybody else. The same thing I think will happen here.
Is our fastest route in something like GT Smalltalk code, or is there something lighter weight to visualize your ideas that you can then add code to?
So this is this lighter thing. It's like, let's go back to DevOps. I remember talking with people in the 10 plus years ago, and they were saying, oh, we don't need to do 20 times a deployment per day because we are already on the path to go from 1 deployment per year to 2 deployments per year. So yes, that's going to be an advancement. Yes, it's better to have 2 instead of 1. It's just not the same thing as going 20 times per day. What we're saying is this is a whole new way of thinking about problems. If people are bringing their old economics and those things, they're probably not for them, not at this moment. They will be convinced when enough people have made a lot of money. I don't think there's another answer for this.
In solving different problems, though, have you come up with other ways of modeling problems that isn't Smalltalk code? I mean, I could write Smalltalk code, obviously, but sometimes like to model and visualize some of these things, it is a bit painful to like create a class and put some attributes in it and blah, blah, blah. It's like, I'm just wondering if there's faster ways to kind of get something visual up and running that you can then augment with code, or whether, like, have you found anything yet, or in your experience, it's just like, just lump it, just write, whack some classes in and just build it up, because maybe that ultimately is the better route, because you've then got the real objects that then you can start to put things onto. I guess that's what I was curious about.
So that's an interesting question, but project costs. So what is the space at which we're projecting costs here? And is creating a class a difficult thing? Well, we found it is difficult. So as a consequence, by the way, the presentation was given in Glamorous Toolkit in one of the pages that I showed you before. But let's say if I say I want some new class, right? and I want to create it. Is it like a difficult? So I just said I have it there. I'm going to create it. Here's the class, some new package.
It's not much more difficult, is it?
I created it, done. And because it's all like the Git thing is going to be even better, more integrated than this. So if I go from here, and if I would have a Git already associated, I would directly create a Git repository, and then boom, I would be up and running within seconds. So
yeah, okay.
I don't.
That's true.
There's lots that can be done at the level of the experience that has never been explored before. And this is not the ultimate solution. This is the beginning of the solution. But I do not believe there is any other environment today that allows the breadth of things to be expressed as what's possible here. If people especially want to learn, once you learn, you can go do whatever. But first of all, learn.
And then I guess what you need to learn a little bit more is just some of the visualization stuff. I can't remember the name of the the Mondrian stuff. Like typically these are the sorts of things that your ideas start. Create a few classes, learn how to use Mondrian to connect a few things together to then start to explore it a little bit more visually, and then that kind of opens the door for you, I suppose. Seems to be what I've seen happen when you've done demos before. Okay. Sure. Graham. Nope, thank you. I'm rolling my sleeves up again.
Okay.
Just a little bit of a further to what Tom was saying. Tom, I recognize your problem. I support what Tudor's saying in terms of saying the barrier, the energy that you need to invest. If you are a programmer, if you are a person who understands software, using G-tools is relatively very low. There is a barrier if you are not that kind of person. If you're purely a domain person, or you're a non-programmer, a non-software person, I think there is quite a high barrier because there's a significant learning curve. We've worked with a tool which we've produced for many, many years called Eva, which is a repository-based semantic repository also done in Smalltalk, but with web-based interfaces which are driven from the domain models which are soft in the tool. And that illustrates the fact that you can take these ideas to a non-programming audience and actually have them come up with domain models in a matter of hours and have live interfaces that they can work with and define a graphical language that they can model in and reason with in a question of half a day. And that gives you, as Tudor was saying, unreasonable comparisons with what typically happens in industry. So yeah, I support what he's saying, but I do think there's work to be done in taking that skill barrier away as well.
Is that tool available for more people, or is that like an internal tool?
It's a commercial tool. It's available on a SaaS basis, but chat to us if you're interested, and we can talk. Put
the link in the chat, like drop it in. It's always interesting to know what other people have. Yeah.
Sure. Mm-hmm.
Okay.
All right. Any more questions? Sorry, my computer crashed. Yeah. Luckily, I had made team co-host, otherwise we would all been kicked out, I think. But in any case, yeah. Has anyone got any further questions?
Not a question, just a comment, but I think that the Glamorous Toolkit is like really, I don't know, like powerful for non-developers. We are using that Glamorous Toolkit in a local hacker space, and we are starting with data narratives, like people use intertwining code and data and visualizations. And the idea of starting with narration, with the story, is powerful. And I think that we were like doing that with another like toolkit, another tool I made, but Glamorous provides like a really fluent experience in that. And I think that there is a lot of potential again on this idea. I think that the the genie is outside of the bottle. We already have this tool, and we are not going to give up on it. No, we are going to keep using it and to use for this kind of civic tech stuff. So there is a lot of potential in Glamorous Toolkit, and I think that potential crystallized really well with non-developers because of the let's say affordances it provides for storytelling, for data storytelling. So yeah, it's just a comment about this idea that this tool can be, I think, better understood by people who is not a non-developer, because they don't have like the, let's say, the way of thinking formatted by the previous tools. This is people that is willing to tell a story, and they are willing to tell a story with the tool that serves that purpose well. And it can happen with Glamorous, because they are not thinking in the, let's say, developing experience or the IDE or the, I don't know, test driven development. They are not thinking about any of that. They are thinking how this technology allow us to understand and express a complex problem. And I think that Glamorous and this idea of moldability is really well suited for that.
Thank you for the comment. Unless there is any last minute thing, I'm gonna stop the recording.
I've got one question, which is totally unrelated to the actual philosophy of the Glamorous Toolkit, but is actually to do with its name, is in that it looks really nice, and the graphics and the fonts and everything like that is very different to the Faro environment. And I was just wondering if you could sort of comment a bit about that, as to how you've got it looking so glamorous.
So we actually built a whole graphical stack, which is new, and it has this interesting property of being everything that you're seeing rendered at any given moment in time is, for example, here is everything happens in the same in a single rendering tree. So I can take anything from here, including this, I don't know, this piece of this word over here, and if I look at it, it's in this tree, and there's only one of them. And this is not morphic, so but of course it is heavily inspired by morphic, among other things. But this was an interesting journey for us. So we wanted to be able to produce something that is reasonable for this century, and we started to build a graphical stack as a team of handful of people. Although this was not the main subject of what we were doing. So, in most other cases, people would use the existing stack that exists somewhere. We spent our energy building one. Not sure if this is advisable for everybody. I'd probably do it again. It was an enormous joy to do something like this. We're still refining how that part of the work, that part of the system quite a bit still. So we think that we're going to have a few interesting things happening in the next period of time in that space as well. But just being able to so let's go and dive into one of these. I'm gonna look at this page, right? So here I have a link to something, and there is this little triangle. In fact, this link is produced by the syntax highlighting as we type, right? So this thing alone is very hard to do. In fact, I do not know of another graphical stack where you can do this one in a reasonably performant way. I don't know. This is like a full thing happening. So this was one of the motivations for why we built a new graphical stack. So this is on that one. On the other hand, we have the design of it. So, and the philosophy that we take there is, It's actually written on our web homepage of if you go to gtoolkit.com. But we wanted to have things that are focused on, but the difficulty here was, okay, yeah, we have fonts and we have, you know, how things should look like. But the thing here was, right, with the moldable environment, you have to create an experience for something that you have no clue how it will look like, because people will create their own views, which means that it's so important to be able to. So if I go back to an example here, this one, right? Here we have a piece of code, we have an object, and then we have an editor embedded in it, and all of them are live. And we still had to be able to empower the one that works with the environment to be able to express something like this and still not be completely confused. So there are no overlapping things. So we have things like, also in the whole environment, there is no modal dialogues. And we can implement the whole experience with 0 modal dialogues, like fully modal. Semi-modal, yes, but not fully modal, right? So for example, here, if I look at something like this, this is a widget that we've implemented. And it's, again, we spent an unreasonable amount of time to implement something like this, just so that it fits exactly, you know, like this thing that you see here fits exactly where this thing was. And there is like, you can embed complicated flows because of this. So we built we built a new kind of a UI language so that we can express what we wanted to do, right? And then if I'm here and I can say, oh, here's another piece of thing, and I say, now I need to write this, and I still need to be able to handle everything without being confused. And then if I go into an inspector of this, of the whole scene, it should still be reasonable. And it still kind of is, right? If you learn the language, which is not that hard, it's kind of understandable. So we spent a reasonable amount of effort. It's just not always visible. We spent a reasonable amount of effort finding what is that language. This is why we're saying the environment is the language, and that language is reflected into the architecture, but it's also into the way the UI comes together.
Okay, thank you very much. Yes, I was actually pertaining more to the sort of low level rendering of fonts, and so that's presumably the block.
Yeah, that's block. Yes.
Subsection or subsystem rather.
Right.
Of it. Yeah. Okay. Thank you.
Welcome.
Great job.
Thank you.
All right.